Here we are in section 4.1, and here we are going to be solving triangles, and we have actually been doing this for quite some time throughout this semester, so a lot of this stuff will be review. We start out with example number 1, and we have the triangle that is shown. We have a 7, a 3, and the angle we're interested in is there, and we're asked what is the sine of theta. And in order to do sine, we know that is opposite side over the adjacent, and so we are ready to, or what we have to do, is to just find the hypotenuse here. And the hypotenuse is the square root of 49 plus 9, 58, square root of 58. And so the sine of theta would then be 7 over root 58, which of course equals 7 root 58 over 58. And that is the final answer. Same thing with number 2. We have this triangle as shown, where theta is down here. We have an 8, a 7, and the right angle right there. And we want to know what is the tangent of theta. Well, tangent is the opposite over the adjacent leg. Well, there's no need to find the hypotenuse here, so that would be 8 over 7 as the final answer. Example number 3, we have this triangle. Right triangle right there. 8 with theta there and 9 there, and we want to know what is the secant of theta, and that does require the hypotenuse. And so the hypotenuse would be the square root of 145, and the secant of theta is the reciprocal of cosine. Cosine would be adjacent over hypotenuse, so the reciprocal would be hypotenuse over adjacent, and there is the final answer for that. Continuing with the next group of problems, it's example number 4, and it says find the exact value, do not use a calculator. This is where we need to use the cofunction of complementary angles are congruent. And so what should really tip us off here is that those two angles together would form a 90-degree angle, or are complementary of each other. Hopefully these are cofunctions. Secant is a cofunction of cosecant. So it doesn't really matter which one we change, but we can do it this way. The secant of 80 degrees is equivalent to cosecant of 10 degrees. And then if we leave the denominator alone, this becomes -1. And so the final answer for number 4 is -1. And number 5, we're told little b is 8, so that's opposite angle B. Angle A is 25 degrees, and we need to find little a, little c, and b. The easiest one to find is angle B, because we know angle B and angle A have to be complementary, so B is simply calculated as 90 minus 25, which would equal 65 degrees. So we have found little b. But what we can do now is we can figure out, okay, with respect to this angle right here, and we like to use this angle because this one was calculated. It's not difficult to calculate, but we do, just in case we made a dumb mistake, we don't want to really use that 65 degrees. So let's just say I want to find little a. Well, with respect to this angle right here, little a is the opposite leg and 8 is the adjacent, so we should be able to use the function tangent of 25 degrees should equal a over 8. And so a would equal 8 times the tangent of 25 degrees, and the directions do say round to 2 decimal places if necessary. And if we look at this, we do see that 25 degrees is not in our table, so it is somewhat necessary. 8 tangent of 25 degrees is equal to 3.73. Now, this is a good rounded answer, but it is not an exact answer, and so we're not going to use it. And even if it were an exact answer, we still wouldn't want to use it because it is calculated. Instead, what we're going to do is we're going to go back to this one right here. This angle was not calculated. This side was not calculated, and with respect to this, the hypotenuse, that's the only thing that's missing. So with respect to this angle here, we know the adjacent leg, and we want to find the hypotenuse. That would be cosine. So the cosine of 25 degrees should equal 8 over c, or c would equal 8 over the cosine of 25 degrees. And to get an approximation here, we just calculate this, and we get 8.83. Now, just to verify, we would probably want to see, does this make sense as far as the Pythagorean theorem? Does 8 squared plus 3.73 squared equal 8.83 squared? And I think if you do that, you will see that that is indeed the case. Example number 6, and in fact the rest of the problems here are word problems, so we basically need to be able to read these problems and then to draw the appropriate figure. So far we've only been dealing with right triangles, so we need to somehow be able to get a right triangle. A survey is measuring the distance across a small lake. So this is my distance across the small lake, and that's what he's trying to find. He has set up his transit on one side of the lake 130 feet from the piling that is directly across from the pier. From his transit, the angle between the piling and the pier is 60 degrees. What is the distance between the piling and the pier to the nearest foot? Well, we look at this. 60 degrees is here. With respect to this angle right here, we know the adjacent side, and we want to find the opposite leg. And so that would be the function tangent. So tangent of 60 degrees will equal x over 130, or x will equal 130 the tangent of 60 degrees. Now normally we would want this to be an exact answer because we could calculate the tangent of 60 degrees very easily, but the directions say specifically round to the nearest foot. So then it's just a matter of taking 130 times the tangent of 60 degrees, and we see that that would be rounded to 225 feet. Example number 7. John, whose line of sight is 6 feet above horizontal. So we've got John. This is a very lovely picture of John standing at 6 feet high. Is trying to estimate the height of a tall oak tree. So there we've got that. He first measures the angle of elevation from where he is standing to be 35 degrees, which means this angle right here will be 35 degrees. Then he walks 30 feet closer, so we know that distance right there is 30 feet, and finds that the angle of elevation has increased by 12%. So this angle of elevation right there would be 12% more, or 12 degrees, not percent, or a total of 47 degrees, and estimate the height of the tree rounded to the nearest whole number. So this whole distance here is what we want to find. Now the big thing that we need to really concern ourselves with is we have two right triangles going on. We have this right triangle here, and we have this right triangle here. And they do share a side. the entire side right here. So I'm just going to I'll call this distance right here y, from the top of the tree to the visual line or the horizontal line of sight. But the problem here is that we need to also deal with this particular distance right here. Now realize this particular example is actually easier to solve, but we aren't quite ready for that using the law of sines. And so if this were next section, it'd make a whole lot more sense. But right now, we're just going to let this be distance of z. So if we look at this small triangle, we know that the tangent of 47 degrees would be y over z. But if we look at this bigger triangle here, we would know that the tangent of 35 degrees would equal y over z plus 30, because we have this whole length at this point right here. Now the trick is, first of all, or what we want to do is we want to find what y is. So let's, if we let y equal the tangent of 47 degrees times z would equal y, or y might also equal the tangent of 35 degrees times the quantity z plus 30. And what we can do is we can distribute this over here, and since they're both equal to y, set them equal to each other. So z tangent of 47 degrees must equal z tangent of 35 degrees plus the tangent of 35 degrees times 30. So just put the 30 out there in front. Now let's get the z's all to one side, so it'd be z tangent of 47 degrees minus z tangent of 35 degrees must equal 30 tangent of 35 degrees. Factoring out the z here, we get z, the tangent of 47 degrees minus the tangent of 35 degrees is still going to equal 30 tangent of 35 degrees. And then finally solving for z, but this is not the final question that we're wanting to ask, but we do need to know it in order to answer the question. Z would equal 30 tangent of 35 degrees over the tangent of 47 degrees minus the tangent of 35 degrees. And then it's just a matter of plugging in to the calculator. And let's see what we get. 30 times the tangent of 35 divided by the entire quantity tangent of 47 minus the tangent of 35 degrees, and close out the denominator. And we get, rounding to the nearest whole number, would be, well, at this moment we don't want to round yet, 56.44, because this does not answer the question. Remember, we have at least one of those triangles there. We called this y, this was z, and this had 47 degrees. Well, now we know that z is approximately equal to 56.44. So we can calculate that y, looking at this value right here, y is equal to z, which we have in our calculator as approximately 56.44, times the tangent of 47 degrees. So I'm going to just take the value that is presently in my calculator, multiply by the tangent of 47 degrees, and I get 61 when I appropriately round. And so this would be 61 feet. But that does not tell us how high the actual tree is, because we want to know this entire distance here. 61 represents from here to here. So since from here to here it would be 6, to answer the final question, all we have to do is add 6 feet to that, and we get 67